So let's revisit one concept very quickly. Let's say that I had a vertex here and I went from the vertex to the opposite side, but I struck it, the opposite side, at the midpoint. And if I were to connect these, this is called a median. And if you were to do the same thing for the other two sides, there would be a point here that is called the centroid. So we have a vertex running through a centroid, striking the midpoint of the opposite side. That segment is called the median. Here is the property. This is half of that. That always happens with a centroid, where let's say this is 1, this would be 2, and the whole thing would be 3. Or if this is like, I don't know, 4, this would be 8, and the whole thing would be 12. The point is that this guy is half of that, or this guy is 1/3 of that. Keep that in mind. So let's focus on vertex A. And what I want to do is I want to go from A to the midpoint of side BC. So let me connect it with a purple line. And notice what must happen. B prime must be contained by that dotted line because they said in the directions that B prime is a centroid. So let me call this M because that's the midpoint of side BC. So from vertex A through this centroid to this midpoint. Similarly, let me grab this vertex and go all the way to point M. And in like fashion, centroid C prime has been captured because C prime was also a centroid based on the directions. Now, let me switch colors. Let me connect D to A. What I want you to see is that we have two triangles. We have this larger triangle, which is called AMD, and this small little pocket of a triangle called B prime M C prime. And my claim to you is that these two triangles are similar. And the reason for that is because the triangles have one matching side, and they also have proportional sides because watch, this is a median, which means that this is the centroid, and this here is 1/3 of that there. Similarly, this here is 1/3 of that there. So we have proportionality. And by side angle side similarity, we say that this little baby triangle is a smaller version of the larger half. And that gives us this. Because these triangles are similar, we have this parallel to that. And that is key because it can be shown, similar to what we've done, it can be shown that if you do this here, like that there, and if you do this here, like that there, it can be shown that this little blue is similar to this larger pink. And because that's the case, that implies that this one here is parallel to that one there. And since these two lines are parallel to the same line segment, then this is parallel to that. And so that gives us that E prime F prime is parallel to B prime C prime. You do have to show the other two pairs of segments, but you would follow the same argument. So using side angle side similarity and parallel lines being parallel to the same line or parallel, use that argument 2 more times to show all 3 pairs of sides of this hexagon being parallel.